COTSon available to people externally, and this would be a perfect time for you to ask questions regarding to see if COTSon suits your needs. So I'm going to try to explain a couple of concepts first, and then on the second part we'll discuss about how we'll start doing some labs hands-on and show you what certain things that COTSon can do. That it can do a lot more stuff. So the main concept is, because this slide is here because many of the things that we say over and over again, most people think they're different. So this is just some simple words that we use constantly. Like, for example, when we speak about functional simulation, we talk mainly about SimNow. It's any kind of simulation that produces a correct output that has nothing to do with timing or anything related to power or anything like that. That's what the other part of COTSon adds. Then we also speak a lot of time about timers, and timers is any kind of model that tries to model the timing or power or of any kind of device. And when we say timers alone, we normally mean CPU timers. But we may be talking about disk timers, or we may be talking about network timers, or NIC timers, or whatever kind of device. Then we also talk a lot about samplers, and this is one of the things that we allow you to change, and including timers. And samplers are the ones that determine when and what parts of the simulation are interesting enough or representative enough so that you want to go into them at full detail instead of going mainly functional. Then there's also a main problem when we're doing this kind of simulation that we'll talk a little bit more in detail later, which is the interleaving part, which is trying to recreate what the functional simulation has done correctly into an untimed environment. So the functional simulation doesn't know when to do stuff based on our models, because we have our loop is not at that specific point in time. So we have to basically do some magic in order to present the correct interleaving of instructions to the timer models that are a little bit behind. And then we also talk a lot about time prediction. And you'll notice later that since we're not a tightly coupled simulation environment, every time that you do something on a timer, for example, that the CPU timer determines that one instruction should have taken so much, we have to give that back to SimNow at a specific point in time. And that is a complicated issue. So we publish some research papers on the topic, and we normally have a model that's called time prediction, because among other stuff, it predicts what the time should be for the correct execution to work correctly. Okay, so one of the first things that we did when we started Project COTSon, I think it was even before we met AMD, was we decided that everything should be decoupled. We couldn't build yet another simulation infrastructure in which every model or every functional emulation was completely tightly coupled, because doing so would mean that it would limit ourselves a lot. On the other hand, by using a decoupled architecture, what we have is that we cannot get the same precision and the same kind of things. There are certain things that you cannot do in COTSon. Like, for example, if you determine that one particular instruction is going to have to take so many cycles, you cannot tell that instantly to SimNow. And we'll talk a little bit more about this. And the other thing that we wanted to do is go fast, because we believe that system simulation infrastructure is as good as the coverage of the code that it allows you to simulate. So we put a lot of emphasis in all the interfaces with SimNow and with a functional simulation, so that they were as fast as possible, as less intrusive as possible, and that they let you decide the relative accuracy versus speed that you want. So we don't want to have one unique type of simulation to say, okay, this is the accuracy that we have, and this is the speed. So you can basically trade one for the other one. This is the COTSon architecture main diagram that it took us a long time to try to fit everything on one page. So COTSon is a cluster architecture. So SimNow is basically a one-node element functional simulation, and SimNow is this pink thing over here. SimNow, as you've seen, is very, very complicated. This is a simple thing that we try to simplify there into the image. And we interface with SimNow at various different points in time. So we decided at first that mainly each device can have its own timing model, but we would first only focus on disk, network, and CPU. And when we mean CPU, we mean CPU on the whole memory hierarchy, because those were the most interesting to our group. But basically, we can talk to the AMD people and ask them for this same interface in any kind of device. So what we do is when we start one sim now and we hook to each of the disks and networks our own timing models. This kind of timing models over here, they are synchronous, meaning that whenever sim now does something, it asks us how much this is going to take. We send it to our timer, and our disk timer, which may be, for example, this sim or whatever kind of timer, determines so this is going to take 1 second, 1 millisecond, 1 microsecond, and we give that to sim now. Of course, doing this at the CPU level is prohibitive, because as Teresa told you, if you stop the translation, well, the dynamic execution in the dynamic code cache of each instruction to call an external function or whatever that tells you the exact same time that how many cycles a particular instruction took, you might as well go to a totally coupled infrastructure where you are already very, very slow, simulating the whole system. And there's another problem with that approach, is that most CPU models cannot really tell you instantly how much the CPU is going to, how much the instruction is going to take. Because instruction has to be decoded, and another instruction is being decoded while you're issuing that instruction, and when you go to memory, you have a power recorder model. So what we decided is to have a totally asynchronous interface over here, and so we asked him now for a series of events. COTSon parses those events and sends instructions to certain models. And at specific moments in time, which is programmable, and that's where our speed comes from, we extract the information from the timing model and determine what type of, what IPC should the CPU execute at. That's why we have a timing feedback that goes back at specific specific moments. And then there's other things that can be seen here, like for example, there's a sampling there. When we talk about sampling, we only mean CPU sampling because this is so fast that we don't really need to sample disk. You can put the disk models always on and the network models always on, and we only sample when and when not to simulate the CPU. And then the last part is that once you have one node running, you can have another entity which is called the network mediator, which basically hooks each of the nodes that you put running together. So every time that one packet that the operating system running inside SIM now issues a packet to the network interface card, we capture that packet, we send it to our network mediator. The network mediator is like a functional switch, sends it to another node, but it also tells that specific node when it should be receiving that packet, because we have a full network timing model there. So we have topologies, and we can simulate different kinds of latencies, bandwidths, and different kinds of stuff in the network. And that is basically what COTSon brings to the picture. So this is very complicated. Stop me at any moment if you feel that something wasn't explained, but we'll go that over and over. Okay, so timer or CPU timer or device model timer. The CPU timers are like our models. We allow you to build our own models with our SDK, but they're not only CPU models. There could be, you could put more than one together, and some of them may just be like fake models that allow you to do profiling, that allow you to do a dump to a disk, to a trace. Some, we've programmed our own mechanisms to do a SIM point analysis. I don't know if you're familiar with SIM point kind of samplers, but they need to process a whole lot of instructions, so we've implemented SIM point in COTSon. And it's very simple to add one. So one of the things that we're going to show later is how to add a very simple timer and how to build your own timers. But you can also put many complicated timers there. So you could basically get simple scalar and put it into our infrastructure. We've implemented PTLC in the previous version, and we put it inside COTSon. So COTSon basically gave all the instructions to PTLC, and PTLC was responsible for determining what's the IPC of the next chunk of instructions, and then we feed it back.